Now, the same branch function, right? And now within this function, we don't need to apply an isolation rule, right? We don't need to consider variables here because now we have a continuation of a developed system, right? And in which that we can still apply no matter whether we have mass, whether we have energy, right? Whether we have a state of a system of change. The fact of the matter is that we have way to tell what it is and where it's going, right? In a system in which that it's balanced, whether we can control the system or whether the system equals c squared, right? Based on the start of the equation, right? We will still determine, right, whether it's a plus or an equals at this point, a times, or a divide, right? And now we can kind of be a little hybrid here. We can kind of be a little hybrid here because we remember this constant, right? We made this 9 times 10, 16, right? But in theory, we can change this constant to whatever we want, right? So at this point of the equation, we realistically, we end up in another loop system where we're still unable to create these properties because this x doesn't exist, right? Because within this system, we can only get to this point, realistically. Because this point's limited, right? At this point, we can't do this and that and that and this and blow things up or strike matches against max boxes and things like this. So without limitation, can we cross this bridge where we have particle data to this point? Well, yeah, we know what the particle is, right? We can give it geometry, right? We know this particle we've incorporated, we've given it weight, and we've had weight established, right? So those things are still properties, right? Whether we would have gotten to this point in Einstein or not isn't the point. The fact of the matter is